Question 37 is the best of the best because we are trying to maximize the capacity of this cup. So we're trying to maximize volume. And you know that this is going to be a cone. And the formula for volume of a cone is 1/3 pi r squared times h. And all we know is that the radius of this piece of paper is r. But here's what we're going to do. We're going to form this into a little cone. And look at what's going to happen, right? So this is going to become the slant height. And from that, okay, so let's see what we have. So this is the radius of the cone, and this is the height of the cone. And what we know then is that we can use the Pythagorean theorem for this relationship. R squared plus h squared equals capital R squared. I'm going to isolate the h. So h squared is r squared minus r squared, so h is the square root of those. Again, do not simplify that. Do not think you can take the square root of that. So now our volume is, I'm going to write this as pi over 3 r squared times the square root of that. And let's see about this little r. The smallest little r can be is 0. And the largest that little r could be, well, imagine this. As little r gets bigger, h is getting smaller. So the largest that little r can be is when h squared is 0 there. So in other words, little r squared is equal to big R squared. Good, so there's our domain for little r. Okay, I'm going to take care of these endpoints. Oh, I can't really plug it in because I'm not including them. The limit as little r approaches 0 for this volume is definitely going to be 0. The limit as little r approaches big R is also going to be 0. So we just need to find something that's going to top 0. Okay, so let's do this. Let's take our derivative. I'm going to carry along that pi over 3. Product rule, derivative of the first times the second, plus, I'm going to carry along that pi over 3 again. Okay, I'm really just carrying that and distributing it. First times the derivative of the second, 1/2 r squared minus r squared to the negative 1/2. This is a constant, so we're just going to have negative 2r. Let's clean that up. Let's set that equal to 0. So let's see, we're going to have pi over 3. We're going to have 2r square root of r squared minus r squared. These 2's will cancel out. This is going to become minus pi over 3 r to the third all over square root of r squared minus r squared is equal to 0. I'm going to divide out those pi over 3's. I'm going to multiply both sides by the square root of r squared minus r squared, which is going to give me 2r quantity r squared minus r squared minus r cubed is equal to 0. So 2r r squared minus 2r cubed minus r cubed is equal to 0. 2r r squared minus 3r cubed is equal to 0. Let's factor an r out of each of those. So we have 2r squared minus 3r squared is equal to 0. So either r is equal to 0 or 3r squared is equal to 2r squared. So r is going to be 2r squared over 3, square root that thing. So that's telling me that r is r times the square root of 2/3. And now all I need to do is plug this into my volume function. So that's going to give me pi over 3. I'm going to have this thing squared, which is 2/3 r squared. And then I'm going to take the square root of r squared minus, again, this thing squared. So that's going to give me pi over 3, 2/3 r squared. This is going to give me the square root of r squared over 3. So this is a little complicated. I can take the square root of the top, right? So we're going to have a pi we're going to have a 2, we're going to have r to the third, and on the bottom we're going to have 9 root 3. So there's our volume, and that is certainly greater than 0. So we're looking for the maximum capacity of such a cup, and this is it.